In this video, I'd like to walk through the InstallationTest R script. This script uses R to create a workflow of tasks. We'll look at some of the functions in the DDMoRe R package and how we can use it to pass information to other packages like Expose and MLXR. Before we start, let's take a moment to have a quick look at the MDL model file we'll be working with. This is a population pharmacokinetic model describing kinetics of warfarin following a single dose. And we're using an analytic solution for the model prediction. We can fold the code to see the four main objects within the MDL: the task, model, parameters, and data objects. In the R script, we first need to set the working directory. Note that the MDL IDE starts with a built-in working directory. This is the workspace folder in the MDL IDE folder of the SEE installation. The first DDMoRe function we look at is getMDLObjects. This retrieves all MDL objects from an MDL file. In this example, there are 4 objects, and the names of these correspond to the named objects in the MDL file: the data, parameters, model, and task. So getMDLObjects returns an R object, which is a list, and we can work with that list in R as we would normally. There are other DDMoRe functions that get specific types of objects from the MDL files. The next step is to perform parameter estimation, which uses the estimate function. And we can specify that we wish to use Monolix as the target software. In behind the scenes, the SEE performs the translation to PharmaML and then to MLXTran, performs estimation, and returns a standard output object, which is then imported into R as an R object. Within the working directory for estimation, we also get the translated code and native Monolix outputs, which allows us to see how the model was translated. We can open and run the project in Monolix should we need to. This aids reproducibility in future for anyone that doesn't have the DDMoRe Interoperability Framework. The getPopulationParameters function acts on the R representation of the standard output object and returns the population parameter estimates. It can also return the precision and interval estimates for these values if requested. One of the benefits of using R is the ability to use pre-existing R packages for workflow tasks. Here, the DDMoRe function, as.xpdb, takes the standard output object and converts it to an Expose database object, so that we can then call Expose functions to perform model diagnostics. Normally, Expose works only with the non-mem output, but here, because of our standards, we can perform the same diagnostics for Monolix. Next, we'll repeat the same process, but estimating using non-mem. Note that we haven't changed or recoded the model at all. We simply specify a different target software. We have access to the translated NMTran control stream, and we can examine non-mem output files if we need to. Again, we perform model diagnostics using Expose, and of course the results look very comparable. Next, we want to update the initial parameter estimates in the parameter object to reflect the final estimates from non-mem before we perform a visual predictive check or VPC using the target software Perl Speaks Non-Mem or PSN. The key function from the DDMoRe package here is the update parObj function. We can view the object to check that the initial values have been updated appropriately. We can then create a new model object group or MOG using the updated parameter object and write that MOG out to a new MDL file. Next, we perform a VPC using PSN. This translates the model to NMTran, then executes the VPC using PSN. Note that we can specify PSN VPC options with the corresponding argument in that function. Finally, we can predict or simulate new profiles using the Simulix function from the MLXR package. The DDMoRe package has a function to write the model to a FarmML file, which can then be used as the input to the Simulix function. Simulix requires us to define the appropriate inputs and design for simulation. But once we do this, it's a very simple task to generate new profiles and plot these. There's an HTML file provided showing all of these steps and expected output. This file was generated with R using the spin function from the knitr package. It also illustrates how we can use R to prepare quick reports. If you have any questions or comments, please let us know via the DDMoRe.eu forum. Thanks for watching.